Good morning and welcome to another one of my 1 hour builds. Last time didn't go so well, so I decided to have a do-over. So without further ado, we're building rock, paper, scissors again. Right, last time we got hung up on the test-driven development aspect of things, and specifically on the supervisors not restarting properly in between tests and getting all kinds of clashes. I'm happy to say that thanks to the phenomenal help from the Elixir Slack group, I've now got that resolved. So let's make a start. We're gonna set the seed here, and so that we force randomness. This actually allows us to make sure that the tests are properly random when running inside of Livebook. And we're going to start with a game test. And we're going to start with a canary test. And run. That should do it. Oh, yes, we need to use xunit.case and set async to false for it to work in Livebook. Cool, okay. So, I realized as I was practicing that we probably don't need a separate round module now that it's not maintaining any state. So we're going to just build a game module straight off. So def module game 2 and actually let's write the test first. Describe, and the most important thing that this needs to do is judge inputs. Judge, let's call it compare. Okay, so assert that game dot compare inputs, and actually we need to actually have a test here, and let's test for draws first. So same input draw. So assert compare inputs rock comma rock is equal to draw. Right, and we run that, and obviously it's going to fail because we haven't defined the function, so we can define it here. And the easiest way to make this pass is just to say, well, you always return a draw. And this is the key to the test-driven development, red-green refactor. Obviously, this is a stupid implementation, but it passes the test. So then how do we make our tests better? What we can do is we can actually make this a random value. So input is equal to rock, paper, scissors, and we pass that to enum.random. And then what we do here is we do input comma input, so these are the same. And of course it always passes because we don't care what the input is, we always return a draw. So next we can test all input draw. Now let's rock, paper, scissors. And what we're going to do here is we're just going to input the whole thing. In fact, just copy the whole thing. Again, we know this test is going to pass because we're returning random all the time, which kind of means we should probably write this a bit later, but we started, so let's get going. And again, that's going to pass. But now, if we do test and we say rock wins do and assert game.compare inputs, and we're going to give it a rock and and scissors, and that should be rock, and that's going to fail. Going to fail because apparently I can't code. There we go, let's try that again. Okay, so I'm going to draw because that's the only thing we're doing. So what we're going to do is we are going to add an additional clause here. I'm going to define compare inputs. And here we're going to say do the minimum to make that test pass. So rock, scissors, and we're going to do rock. There we go, that test passes. Okay, now what happens if we give them in the opposite direction? So scissors, rock. That test now fails. Now we could just create another clause, but that gets a bit stupid. So what we're going to do instead is we're going to make this private, and we're going to say compare, and in compare input, what we're going to do is we are going to capture this input, and we are going to input, and we're going to do enum.sort, and then we're going to pipe that into compare. Okay, now let's see. Okay, yeah, because we don't have that clause now, so def-p compare. Anything else, we return a draw. How does that look? Yep, all those tests are now passing. I'm just going to move this to the top, and yeah, that should be fine. Okay, so now I want to add one more test here, and that's to make sure that we still support multiple options, more than two options. So, there we go. So when we have more than two options, two inputs, then it doesn't work. So all we need to do here is we can pipe that into enum.unique, and then we can pipe the output of that into the rest. And that passes. Cool. Okay. Now we want to make sure we can allow paper to win. So paper. And this needs to be scissors. Okay. So what we need here is another clause, and we're going to say paper, scissors, and scissors wins. Mm-hmm. Ah, what am I doing? Oh, paper and rock. And paper wins. There we go. Hope if I paid attention and didn't go into autopilot. Oh, okay, right. So paper wins, and now we get scissors wins. Now, okay, that fails, and all we need is another clause, which is paper and scissors. Oh, that's the core of our game logic, and it supports arbitrary numbers of players, which is cool. Okay, now this compare inputs function is the core of it, but actually we don't care about which input wins. We want to actually have a specific player. So we're going to have describe a new function, and that's going to be declare result. Now, what do we want this to do? There are two things we care at the end of after judging. We care about what choice won, or whether there was a defined winner, so rock paper scissors, or whether or it was a draw. And we also need to know how many players are left, because if there's more than if you're playing multiplayer and sort of two people choose rock and one person chooses scissors, you then have two people who need to play again in a different round. So we want to assert that game.declare result. What should this take? It should take a map of players organized by choice. So for example, rock will have a list of player 1 and say player 2. In fact, this is the simplest scenario, right? So this is a draw scenario. So it should return, what should it return? Maybe we return a tuple, that's the first item being a draw, and the second one being the list of players remaining. Player 1 and player 2. Okay, let's try that. Obviously the function's undefined, so it's going to fail. So what we can do is declare result. Yep, that should be fine. And this takes an array of choices, which is going to a map choices. And what we want to say is actually in this case, for this first use case, we can just return the tuple just to make the test pass. So, player 1, player 2. Right, it's hard coded, makes the test pass. So what we want to do, okay, we need to actually rub that in the test. Same choice, draw 2. Okay, test, let's add another one. In fact, we can carry on with this and just do that. and just add another player. And this will already show us that our implementation isn't actually doing anything. Okay, so how do we make this pass? The easiest way to make this pass is to remaining players is equal to, and then we can take this map choices, pass that into map.keys, map.values, because the players are the values, and then pass that into list.flatten, because each one will be a list. And then we return the remaining players. Right. Oh, there we go. Cool. Okay, so we can have multiplayer draws. Let's pull this out, it's a bit ugly. So I'm going to say result equals still passing, and then we're going to do the same here. Okay, that's a bit better. Okay, so test rock wins, and we're gonna grab one of these, and we're gonna say we've got two players choosing rock, and let's have another player choosing scissors so that rock can win. Okay, and we assert that the result should be what it should be, rock, and it should be player 1 and player 2 should come back as the winners. I am wondering whether this result should also include what the different options were, but maybe that's not part of the result. Let's see. I might come back to that. Double equals. Cool. Okay, so it needs to return a rock. And at this point, we are very much needing to figure out who actually wins. So what we can do is do a case of choices, pass that into compare inputs. No, we need the keys, don't we? Choices, so we grab the map.keys. That will give us a list of rock, paper, scissors, etc. And then we can pipe that into compare inputs. And that will give us either a draw, which is what we do here. In fact, we can just, can grab both of these lines. Or it will give us a winning choice, winning input choice, it doesn't matter. Right. And if we have one, then what we do is we return a tuple, which is the winning choice, and the players from that map. So we'll do choice at choices at winning choice. So these will be the remaining players. Yep, and then that passes. Cool. Okay. Do we need anything else? Well, rock wins does that. I've gone too far, I've implemented too much. And let's see. That's annoying. Because we flatten. And we can't flatten. Well, we can flatten, but does it matter? Probably doesn't. Let's just do it like that for now, and we'll see if it complicates things in the future. And again, we can make sure that scissors can win. Okay, right, so all of those tests are passing. We can declare results. We can compare inputs and declare results, declare winners. What else do we need for a functioning game of rock, paper, scissors? We need to be able to accept inputs, or some way for the players to actually interact. And we need to keep track of players. And I think this is where we start needing a little bit of state. So we're going to change our game into a gen server. Yeah, so that players can asynchronously register their choices. So describe, what's this going to be? It's going to need to accept handle inputs. So we are going to want to say something like, how is it going to accept these inputs? I think the best way to do it is over a pub sub. So we are going to add a setup block. This needs to return OK, and we're going to do Phoenix pub sub start supervised, and then we're going to do Phoenix pub sub name pub sub, and that should start the supervised process. But obviously, I haven't installed Phoenix pub sub, so there we go. We can add that. And is that starting correctly? Yeah, that should do. And it means our game is going to be a gen server. It's going to subscribe to its channel, and then it's going to send and receive messages on that channel. and on the players' channels, but we can do that in a second. So handle inputs, we can do phoenix.pubsub. Well, we need to start our game first of all. So gen server dot start link game, comma, initial args will be a list of players. And let's give it a name that is just a game. And then what we can do is we can try to run that, and we already know that's going to fail. Yep. Cool. So what we can do is use gen server. Oh, come on. That's it. Def init players do, and we're going to return OK, and we're going to return a state which is going to be players, and we're going to keep track of a list of choices. Oh, a map of choices actually. Okay, and over here we're going to do phoenix.pubsub.subscribe to pubsub, and the topic's just going to be game for now. Right. Unknown registry pubsub. Why? Let's just see if this is a weird glitch. I'm just going to close this and reopen it. Why is pubsub an unknown registry? Let me just grab this from here. And let's just put it in here. Hexdocs.pm xunit. Maybe I just need to start link. Why? That's the correct name. Is this even running? Yes, it is. So why? Why is Phoenix PubSub not starting? Right, let me just make it in here. So, start link, and that needs to be phoenix.pubsub, and the args name pubsub. That one it is. What? Yeah, so this works. Just need to be already started. What? Okay, yeah, because I've started it up here. Okay, so if we reevaluate that, and now registry. Why do I not get any? I really don't understand what's going on here. So if I start it here and take it out of here, I can use it. So why can I not start it here? Let's just put it in here. Only being invoked from the test process. It is being invoked from the test process. Oh my goodness, really? Wow. Just wow. Yeah, less said about that, the better. Okay, so that initializes and subscribes to the game topic, and then we can do phoenix dot pubsub dot broadcast to game with the pubsub module, and the message will be it should be play, and it should be the name of the player. Player 1, and then it can be the choice. And what do we assert? How do we know that this is actually working? Maybe what we do is we implement a log channel, and the game can log what's happening. So we can do that. In fact, we can subscribe to a log channel. Subscribe pubsub topic's gonna be log, and what we want to do here is assert receive, and then we want to figure out what is going to get logged. So it's going to get log input received, and we're going to have player, and we're going to have the input. This is a log channel, so it's not going to so actually here we go. This isn't going to be visible by the other players, but it allows us to check that everything's happening the way it's supposed to. And obviously that's failing, so we need to def handle info. And we're going to get play, comma, player, comma, choice. And we're going to get state. I'm going to do return no reply, comma, state. And we're going to do phoenix.pubsub.broadcast to pubsub, and we're going to call it broadcast to the log topic, and we're going to say input received player comment choice. Okay, and that is passing. So it receives inputs, and then what does it need to do with them? And more importantly, how are we going to test it? It needs to add them to the choices array. What if it was to log its actual state? That would allow us to map to figure out what's going on. Okay, let's try that. State, and we are going to have here a map choices, which is going to be a map, and that's going to be rock. And then in there, we're going to have player underscore one. Now that's going to fail. So what we need to do is okay, and we need to check in here. We need to actually update our state, so we're going to do map. So state is going to equal to state. And I'm going to pass that into map.update. And we're going to update the choices key. And the default, if there's no choice already for that, it's going to be a list with the player in it. And the function is going to have a list of players. And we're going to prepend our player to the list of players. No, hold on. Choices is a map. So what we're going to do is we can do update that because we know choices is player present, so we don't need that. And this is going to be choices. And then what we're going to do here is we're going to pass choices into map.update. And we're going to update the key, which is going to be the choice. And we're going to use update 4 so that we can pass a default value. This is going to be the player default value. The actual list, and then fn players, and then players. How's that looking? Okay, right. So because it's trying to match against the whole input. That's a bit annoying. It's fine, we can grab that. Okay, and it needs to send its state. I wonder if we can get rid of this now. Don't think we will. Yes, because it's matching the map. Cool. So it needs to register inputs. And we do have a described here. Input handling. So we know that it can take inputs and register them in the choices map. We need to do what? We need to prevent multiple entries. So basically we need all of this. And what we need to say is if we duplicate that, we know we're going to duplicate the assert receive, that's fine. But the output is going to be the same. We're not going to have two lots of player one. Now that should fail, shouldn't it? Okay, so because it received that first. Okay, that's it. Yeah, so what we need to do, let's think. If we keep a track here of pending players, and then that can just be our list of players, right? And then when we get an input, we can do if, let's pick that out, pending players, if enum.member pending players player to. So if they are a player, then we do all of this stuff. And in fact, we can move that to there. Otherwise, we return the state as it is. The other thing we need to do here, we need to update update pending players and what we're going to do here is going to do players, pass that into list enum.reject, and we're going to reject the input which is equal to our current player. And all that means is that when the player plays, we remove them from the list, and therefore next time around they're not in the list, so they can't have their input registered. Let's see how that's looking. Yeah, that's looking a lot better. Okay, what do we want to do next? We've got 10 minutes left, and it would be nice to be able to bring this to a bit of a close. So we need to see, once we've had all our inputs, we need to trigger our declare results, and then probably log out the inputs. Right, so describe and round, or maybe round handling, do test declare results when all players have played. Okay, and what we're going to do is very much the same that we're doing here, and in fact we can pop some of that stuff in. We can pop some of that in a setup block. Make sure all that's still okay. Yes, it is. Cool. So we can get rid of that. I'm going to copy this setup block because it applies to that context above as well. And we're going to start a game. And I'm going to start with 2 players. And we're going to make sure both players play. So that's going to be player 2. And then we are going to assert receive. And what we want to see in the log is something like round finished, and then we want the result from here, which will be a draw with that. Of course, that's going to be fail. Okay, yeah. Okay, right. So what we want to do here is we want to check if length of state dot pending players is less than 1. Oh, in fact, we don't need that. If we need empty, enum.empty, and we can do state.pending players. There we go. And then we can do what? What do we want to do? We can do process.send after, and that can be declare result. The destination is going to be self, so we're going to send a message to ourself. It can be declare result, and we're going to wait. Well, we don't need to wait anymore, any length of time. And then what we do is def handle info declare result, comma state do. Okay, we're going to do no reply state. And what we need to do first and foremost is result is equal to declare declare result of state.traces, and then we're going to say phoenix.pubsub.broadcast to pubsub log, and our message is going to be, what did we say it needs to be? Round finished, and the result. We will also need to do another log like this of the state, and we can check the state. And what we want to do is state is equal to state, pass that into map.update. The key is going to be choices. Choices needs to be empty. So fn underscore, because we don't actually care about the input here. Just going to turn that in, get that back into a blank map. And the same for, we're going to have depending players, and that's going to be a list of players. No. Interesting. Okay, so this is where we have some branching logic, but let's not get into that for now. Let's check this first, and then we can come back to it. Okay, player 1 rock, input player 2 rock, pending players is empty. Why is player 2 still pending? Oh, okay. We're getting the right thing, but forget the order here. Yeah, cool. Okay, so that works. We are playing a whole round. Now, what I was going to say here is we need to keep track of a round number, and we need to, if there's more than one player remaining, then the game needs to progress into following rounds. Otherwise, we declare the winner and we exit the process. But seeing as we are at time, that's going to have to be an exercise for the next session. Thanks a lot for watching. Take care. Bye.